All logarithms will follow these log properties. These are just things that are always true when you have logarithms with the same base. There are 3 log properties. They are called the product property, the quotient property, and the power property.
Wait, so the X?
Is the X inside you need to go back?
Yeah.
Oh, actually,
You've done all the reviewing. Okay. And I can help after.
You need
Where's my red mark?
Yeah, I'll just come later, Alexander.
Okay. There's this class is done. I'm good.
Yep.
Okay.
is that X outside or inside of the
It's the base. It's the base.
Okay.
Good.
Wait,
So-
that wouldn't even make sense if it was inside.
Alright, so log properties. Log properties are true for all logarithms, assuming they have the same base. You will need to memorize these log properties, but I'm going to give you a way that memorizing is actually pretty easy. Because I'm going to relate it to something you already know. You're ready. What are logarithms again?
They undo exponents.
Okay, because essentially they are exponents. Yeah, very good. Logarithms are exponents. Okay? Logarithms are exponents, so they will follow all your exponent rules that you were taught in Algebra 1. Okay? For example, here's an exponent rule you were taught in Algebra 1. X to the third times x to the fourth equals what? X to the seventh. Because the rule is, when you're multiplying, you do what with the exponents? You add them, right?
Yeah.
So when you multiply with exponents, you add the exponents. There's your first rule right there. When you have multiplication, you add the exponents individually. That should help you remember the product rule. When you're multiplying with exponents, you add. Okay? Therefore, then, when you divide with exponents, what do? You subtract. So that should help you with the quotient rule. When you're dividing, you subtract the exponents. So far, so good?
Yep.
Okay? And the last one is a power raised to another power. Power to a power, you multiply the exponents together. So, if I have log A, which is an exponent itself, raised to another exponent, I can just simply multiply those exponents together. Alright?
Yeah.
Or what most people just say, hey, move the power out to the front and multiply it. Or vice versa. If there's a number in the front, move it up to the power. Okay? These properties work both directions. So think of these as your exponent rules that you had in Algebra 1. When you multiply exponents with exponents, you add. When you divide with exponents, you subtract. And when you have a power raised to another power, you just multiply the powers together. That's how I memorize them. Okay? You don't need to be able to write it out a certain way, just know how to use them. So some of you might be like, okay, well, how are we going to use them? Okay? Well, actually on Khan, it's going to keep things pretty simple. They're going to give you something like this. They're going to say, simplify log 5 plus log 6. Well, when you have addition, you could rewrite it as a product. So I could rewrite this simply as log of how much? 30. That's what they're looking for. When you see plus, you know you can multiply. Questions? Log 20 minus log 2. Log 10. Because when you subtract, you can divide, right? 20 divided by 2 is 10. And then they might give you something like this. 3 log, I'll keep it easy, 2. Log of 2 to the third, which is actually what number?
8.
8. Log 8. I'll write out all my steps. But so there's some examples of me using these log properties with actual numbers there. They're very basic, all right, but I want to start there. How are we doing on understanding what things might look like using these log properties? Any questions coming to mind right now? Okay. Four log x plus 3 log y minus 5 log z. Now we're starting to get a little more complicated here. This is probably above what con goes into, all right? And I'll challenge you with, a little bit more difficult things than what's on con when it comes to these log properties, okay? But nothing's really much more complicated. There's just more there. Where can I move the 4?
Above the x.
The 3
Same with the
and the
y.
5, right? Let's do that first. So log of x to the 4th plus log of y to the 3rd minus log of z to the 5th. See what I did there? What property did I use on that step?
Use the power.
Power property, right? Okay, awesome. Now I got some addition and some subtraction. I'm going to work with my addition first, okay? I'm going to ignore this guy at the back end for right now. This is a plus, so what can I do with these things?
Yeah.
Multiply them together. So I'd have the log of x to the 4th, y to the 3rd, minus the log of z to the 5th.
You can divide them.
Then I can divide them. So that'd be the log of x to the 4th, y to the 3rd, over z to the 5th. Done.
Oh, you can just not put
I can't really simplify this because the x, y's, and z's don't cancel each other out. Like, if this was an x to the 5th down here, I don't know what you're thinking about, and you can ask me afterwards, but if this was like an x to the 5th down here, then I could cancel some x's out because I have an x to the 4th over an x to the 5th, which would leave me with just an x to the 1st on the bottom.
Could
All right,
you put,
go ahead.
I don't know, log x to the 4th, y to the 3rd over log z to the 5th?
Okay.
Or do you want us to take the log out?
Definitely not. Okay, look at the property. Log of A minus log of B does not equal the log of A over the log of B. It's just a single logarithm. Okay, that's a very common mistake. It's a good question, okay? Yeah, basically, what we're doing is we're taking these 3 logarithms and condensing it down to just a single logarithm. All right? So we're going from 3 logs down to 1 log, even though the value that's being logarithm is a little bit of a complicated looking expression, all right, but it's definitely a lot shorter than having 3 logarithms there. Okay? So, that's a great example of me using essentially all 3 properties within the same problem. The only way, maybe I could make that a little more challenging is I could throw like a fractional power in here. Like, let's say I made this like 1/2. So when I move the 1/2 to the power, I'd get a y to the 1/2 power. Well, a y to the 1/2 power is really what type? What's another way of writing y to the 1/2 power? Square root of y. So that'd be the only way I could make it a little bit more challenging. So this answer at the very end would end up being the log of x to the 4th square root y over z to the 5th. I skipped a bunch of steps there, but that'd be the only difference. So just remember that fractional powers can also be rewritten as radicals. We've talked a little bit about that. Anything to the 1/2 power is a square root. Anything to the 1/3 power would be a cube root. Anything to the 1/4 power would be a fourth root. Yeah? Questions? because I can write out some more things. If this is like, whoa, this is Greek to me, I don't remember all that stuff, I can kind of show a few things. We're okay? Fractional powers are really radicals. Okay? Alright, so that's kind of my brief lesson on log properties. Any questions coming to mind there? Okay? Try that one on Khan here real quick. It will not take you long. Believe me, it's pretty short. I'm going to stop the video.